Hey everybody, how you doing? This is going to be the next video for our physics unit. We're looking at forces, mass, and newtons. And this is going to roughly go along with the Google Slides with those same things in it that's going to be posted in Google Classroom. Okay, so the first part of our video here, we're going to talk about forces. A force is a push or a pull on an object. And Noah and Aiden are here to help me demonstrate what forces look like. And now forces are measured in newtons. And we'll be working with those a bit later. All right, so right now, both boys are pulling on the rope. And so both of the boys, their forces added together is called the net force. Now, right now, you'll see that nobody is winning. Nobody is moving in our game of tug of war here. That is because their forces are balanced. They are both pulling the same amount, so nobody is winning. If one of the boys was to pull harder than the other boys, now we have an unbalanced force. And see, Noah had an unbalanced force. He had a bigger force on than his brother was able to put out, and he won the tug of war. Okay, this is Luna the cat, and we are going to use Luna to demonstrate the property of inertia. Inertia is the resistance of an object to a change in its motion. So if something is moving, a change in its inertia would make it go faster or make it go slower. Or in the case of Luna here, who is quite round, that would be to get her to get up out of this chair and moving again. To overcome inertia, you need a force. So some sort of a push or a pull. And now the bigger an object is, the bigger that force has to be. So Luna is quite round, much rounder than our other cats. And so it would require more force to get Luna to move than it would to get our little skinny cat Mochi to move. All right, we're going to move on from fat shaming the cat and go to the next part. Okay, now we're going to start talking about Newton's 3 laws of motions. This is a wheelbarrow full of paving stones. It is quite heavy. So Newton's first law states that an object in motion will stay in motion, while an object at rest, the wheelbarrow, will stay at rest unless acted upon by an outside force. Thank goodness that this wheelbarrow will stay put where it is until I go over there and pick up the handles and give it a shove or a force. Same thing goes if the wheelbarrow was barreling down the hill here. It would require a force to make it stop. So now Newton's second law says that an object's acceleration depends on the mass that it has. And if you think about it, this one is really the Captain Obvious law of motion here. It basically says that you need a bigger force to put on something heavy, like a wheelbarrow full of paving stones, than you would need to put on an empty wheelbarrow to get them moving or to make them stop. So the heavier it is, the more mass it has, the more of a force is required to get any sort of acceleration. Okay, Aiden is here to help me demonstrate, not yet, Newton's third law, which states that for every action, there is an equal and opposite reaction. So what we have here is a bottle, and the bottle has baking soda, and Aiden has a beaker full of vinegar and a cork, and he's going to pour the vinegar in and then put the cork in the top and then put it upside down, and we hope this works. All right, dude, go for it. Quick, cork! All right, close enough. So what you saw there was the force of the gas created by the chemical reaction of the baking soda and the vinegar pushing on the cork. At the same time, it's also pushing on the out and down on the sides of the bottle. It's how a rocket works, is by using Newton's third law. All right, people, the last thing we got to talk about is momentum. So momentum, you've heard this word before, but here we're talking about physics. We're talking about a quantity of motion. So usually if somebody were to tell me to think about a quantity of motion, I might think about speed. And that's not quite it, though speed is involved. Momentum is about motion and mass. So momentum, which is usually used, they usually use P for momentum, is equal to mass times velocity. So we're going to demonstrate momentum here with, we have a Matchbox car and we have a big wooden fire truck. So Aiden is going to put the Matchbox car down the ramp. And the Matchbox car, pretty obvious here, is pretty small. It doesn't have a lot of mass, so it doesn't have that much momentum. Okay, now he's going to put the fire truck down. Okay, fire truck, obviously a lot more mass to it there, and therefore it has more momentum as it goes down my little wood ramp here. But the thing is that we could, if we worked at it hard enough, we could make that Matchbox car have as much momentum as the fire truck if we got it going fast enough. So think about that for a little bit, and we'll be working on looking at all of these in class time. Thanks, guys. Nice job. Move on to the questions in the reading, all right? See you soon.